Download this code from codegive.com, link in the description below. Deep dive, understanding and addressing red timeout causes retry despite HTTP method used, 1059. The error red timeout causes retry despite HTTP method used, 1059, is a common and frustrating issue encountered when making HTTP requests, especially when dealing with external services or unreliable network connections. It indicates that your application experienced a read timeout while receiving data from the server and, importantly, that your HTTP client is configured to retry the request regardless of the HTTP method used, example post, put, delete. This can lead to unintended consequences, particularly when dealing with non-idempotent methods, where multiple executions can result in data corruption or duplication. This comprehensive guide will dissect this error, exploring its root causes, the dangers of indiscriminate retries, and, most importantly, providing concrete solutions with code examples in Python, a popular language for making HTTP requests. 1. Understanding the components. Before diving into the problem, let's clarify the core concepts. *HTTP method * the type of request being made to the server. Common methods include *get* retrieves data from the server. Idempotent. *post* sends data to the server to create a new resource. Non-idempotent. *put* sends data to the server to update an existing resource. Idempotent. *delete* deletes a resource on the server. Idempotent. *patch* applies partial modifications to a resource. Can be idempotent or non-idempotent. Idempotent versus non-idempotent. An operation is idempotent if performing it multiple times has the same effect as performing it once. Get, put, and delete are generally considered idempotent. Post, creating a new resource with each call, is not. Read timeout. The maximum time your client will wait to receive data from the server after the connection has been established. If the server doesn't send any data within this timeout, the client considers the connection broken and raises a timeout exception. Retry mechanism. The logic in your application or HTTP client that attempts to resend the HTTP request if the initial request fails, example due to a timeout, connection error, or server error. HTTP status code 1059, non-standard while not an official, universally recognized HTTP status code. 1059 is often used internally within specific systems, like load balancers, proxies, or custom applications, to indicate a read timeout condition before a formal 5xx error is sent. The message red timeout causes retry despite HTTP method used is typically a custom message associated with this, or a similar, internal timeout indicator. 2. The problem: uncontrolled retries and non-idempotent methods. The danger arises when your retry mechanism is configured to retry requests regardless of the HTTP method. Consider a scenario. 1. Post request *. Your application sends a post request to create a new order in an e-commerce system. 2. Read timeout *. The server receives the post request, processes it, creating the order, but then the connection is interrupted before sending the response back to the client. Your client experiences a read timeout. 3. Indiscriminate retry *. The retry mechanism automatically resends the same post request. 4. Duplicate order *. The server processes the second post request, unaware that it already processed the first one, and creates a second order, a duplicate. This can lead to data inconsistency, financial loss, or other serious problems. 3. Root causes of read timeouts. Understanding why read timeouts occur is crucial for addressing the problem effectively. Common causes include slow network, congestion, packet loss, or unreliable network infrastructure can significantly delay data transmission. Server overload, the server may be experiencing high load and struggling to process requests quickly. Long-running server processes, if the server's processing logic takes a long time to execute, it may exceed the configured read timeout. Firewall or proxy issues, firewalls or proxies can introduce delays or drop connections, leading to timeouts. Server-side bugs, bugs in the server-side code can cause unexpected delays or hangs, resulting in read timeouts. Insufficient resources on the server, the server might not have enough memory, CPU, or database connections to handle incoming requests efficiently. Configuration errors, incorrectly configured timeout settings on the client or server can exacerbate the problem. Large payloads, sending or receiving very large data payloads can naturally increase the time required for data transfer, making timeouts more likely. 4. Solutions and best practices. Here's a breakdown of strategies to address the read timeout causes retry despite HTTP method used error. A conditional retries based on HTTP method and error type *. The most important solution is to restrict retries to idempotent HTTP methods, get, put, delete, and specific error types that are likely to be transient. Avoid retrying post requests or other non-idempotent methods unless you have a very compelling reason and a robust deduplication mechanism in place on the server side. Python example using the requests library with urlib3 for retry configuration *. Key improvements in this example. urlib3.utility retry. This class provides a flexible way to configure retry behavior. Status _for cellist specifies which HTTP status codes should trigger a retry. We've included common status codes indicating temporary server issues. Method _whitelist crucially, this defines the HTTP methods that are allowed to be retried. In the example, it defaults to get, put, delete for idempotent methods. The make_safe_request function allows you to override this when called to enforce no retries for post methods. *backoff_factor implements exponential backoff for retries, gradually increasing the delay between attempts. HTTP adapter *a requests component that allows you to mount the retry strategy to specific protocols, HTTP/HTTPS. Explicit timeout the timeout equals 10 parameter in HTTP.request sets a read timeout. Error handling the try, except block handles requests.exceptions.request exception, which catches connection errors, timeouts, etc., and requests.exceptions.http error, which catches HTTP errors like 400, 500. Session management using requests.session, allows for connection pooling, improving performance. The http.close statement ensures that the session is closed properly. Clear example usage the example demonstrates how to use the make_safe_request function for get, post, and put requests, explicitly disabling retries for post. B. Implement idempotency keys/request IDs *. If you absolutely must retry non-idempotent operations, consider using idempotency keys. This involves generating a unique identifier for each request, a UUID, for example, and including it in the request headers. The server then uses this key to detect and prevent duplicate processing of the same request. Python example, idempotency key. Server-side implementation, conceptual. The server side needs to store the idempotency underscore key along with the result of the request, example order ID, transaction ID. When a request with the same idempotency underscore key arrives, the server should 1. Check if the idempotency underscore key already exists in the database. 2. If it exists, return the previous result associated with that key, without reprocessing the request. 3. If it doesn't exist, process the request, store the result and the idempotency underscore key, and return the result. C. Increase read timeout values asterisk. If read timeouts are frequently occurring due to legitimately slow operations, increasing the timeout value can help. However, this should be done cautiously, as setting excessively long timeouts can mask underlying performance issues and tie up resources. Consider increasing timeout values selectively for specific endpoints known to be slower. Python example, increased timeout. D. Implement exponential backoff with jitter asterisk. Even for idempotent operations, avoid hammering the server with retries immediately after a failure. Implement exponential backoff, gradually increasing the delay between retry attempts. Adding jitter, a small random variation to the delay, can help prevent multiple clients from retrying simultaneously and overloading the server. Python example, exponential backoff with jitter. Monitor network and server performance asterisk. Proactively monitor your network infrastructure and server performance to identify potential bottlenecks or issues that could be contributing to read timeouts. Tools like Prometheus, Grafana, New Relic, and Datadog can provide valuable insights. Look for trends in response times, error rates, CPU usage, memory usage, and network latency. F. Implement circuit breakers asterisk. A circuit breaker pattern can prevent your application from repeatedly trying to connect to a failing service. The circuit breaker opens when the service is unavailable, preventing further requests until the service recovers. Libraries like pbreaker in Python can simplify circuit breaker implementation. G. Server-side optimizations asterisk. Work with the server-side team to optimize server-side code and infrastructure to reduce response times. This may involve database optimization indexing, query optimization, connection pooling. Code profiling identifying and addressing performance bottlenecks in the server-side code. Caching implementing caching mechanisms to reduce the load on the server. Load balancing distributing traffic across multiple servers to prevent overload. Asynchronous processing offloading long-running tasks to background processes. H. Use a service mesh Service meshes, like Istio, Linkerd, can provide advanced traffic management features, including automatic retries, with configurable policies, circuit breaking, and load balancing. They offload these responsibilities from your application code. However, setting up and managing a service mesh adds complexity to your infrastructure. I understand and honor retry after headers Some servers, when experiencing temporary overload, example returning a 429 too many requests or 503 service unavailable error, include a retry after header in the response. This header indicates how many seconds the client should wait before retrying. Always respect this header. Ignoring it can exacerbate the server overload. Example, checking for and honoring retry after. J. Use a message queue for asynchronous processing. If you are performing operations that inherently take a long time, consider using a message queue, example RabbitMQ, Kafka, Redis pub/sub. Instead of making a direct HTTP request to trigger the long-running process, enqueue a message describing the operation. A separate worker process can consume messages from the queue and perform the operation asynchronously. This improves the responsiveness of your application and avoids red timeouts. Example, conceptual. One application * receives a request to create a complex report. 2 enqueues message * the application enqueues a message on the message queue, example create_report, with details about the report parameters. 3 worker process * a worker process, running in the background, consumes the message from the queue. 4 report generation * the worker process generates the report. 5 notification, optional. The worker process can optionally send a notification to the application or the user when the report is complete. 5. Debugging and troubleshooting. If you're encountering the red timeout causes retry despite HTTP method used error, follow these steps. 1. Examine logs * carefully review your application logs, HTTP client logs, and server-side logs for any clues about the root cause of the timeout. Look for error messages, stack traces, or performance warnings. 2. Network analysis * use network monitoring tools, example dump, Wireshark, to capture network traffic and analyze latency, packet loss, or dropped connections. 3. Server monitoring * monitor server performance metrics, CPU usage, memory usage, disk I/O, network I/O, to identify any resource bottlenecks. 4. Reproduce the issue * try to reproduce the issue in a controlled environment to gather more information. 5. Simplify the request * try making a simpler request to the same endpoint to see if the problem persists. This can help isolate the source of the timeout. 6. Test with different clients * try making the request using different HTTP clients, example curl, Postman, to rule out issues with your application's HTTP client configuration. 7. Check firewall and proxy settings * ensure that your firewall and proxy settings are not interfering with the connection. 6. Summary. The red timeout causes retry despite HTTP method used, 1059, error highlights the importance of carefully managing retries, especially for non-idempotent HTTP methods. By implementing conditional retries, idempotency keys, increasing timeout values cautiously, and monitoring network and server performance, you can significantly reduce the risk of duplicate operations and data inconsistency. Remember to combine multiple strategies for a comprehensive solution. Understanding the root causes of read timeouts and addressing them proactively is crucial for building reliable and robust applications.